In this episode, we will be adding a reticle to show exactly where the player is looking on screen. We will then be changing this reticle based on whether or not the player is able to interact with the object in front of them, or if they are currently interacting with the object in front of them. We will also add collectible objects and set up a signal that would put that object in your inventory. Inventory not included in this episode. And finally, we will add object outlines to show where collectible items are, should your environment be dark and spooky. Welcome back to the immersive simulation controller that we are building here together in this series. I am building this specifically for a horror game, so that way I can incorporate puzzle solving into it. Today we are going to be working on our interaction system. Specifically, we are going to be implementing collectibles, meaning items that you can pick up or put into an inventory, such as health packs or ammunition, things of that nature. As always with this series, we want things to feel very immersive and very clear and intuitive to the player. So we are going to be starting with modifying our reticle. So you'll see in the bottom left in our file system, I did some slight refactoring. I created a folder called assets and I dragged the prototype textures into the assets. As you can see, we now have 3 additional reticles as well. This is just a little white dot that's going to sit in the center of the screen. This is going to be the default reticle. And the reason we want this, if I run the game, you can see that we don't actually know where the center of the screen is. So if I come over to my switch, you can see, and this has happened in previous tutorials, sometimes you can't really get the switch, and then sometimes you do. So the little white dot is going to help the player find where those interactions are. And when the player finds interactions, we are going to change to this open hand reticle. That just tells the player that, hey, this object in front of you right now is something that can be grabbed. And finally, we have the closed hand reticle, and that is if we are actually holding on to a box or we have gripped a door or gripped a switch of some kind. And all of these will swap between each other to let the player know whether or not they can interact, if they are interacting, and will make the game just feel a lot more immersive. So these 2 icons, tile 155 and tile 156, these also came from the Kenney texture packs. It's a different texture pack from the prototype texture packs, but it's from the same artist. Once again, this is 110% completely free. I will leave a link in the description below. So that's enough of an introduction. Let's go ahead and start setting up our GUI. So go ahead and go into your player. Let's look at the 2D view. We're going to left click on our player. We're going to hit Control A and we are going to add a regular node. This node is just going to be kind of a folder node that I'm going to call GUI, and this is going to hold all of our GUI objects as we add more to the controller. On that, we are going to hit Control A and add a canvas layer. The canvas layer is going to be renamed to just be our reticle layer. On the reticle layer, we are going to add a control node. There we go. Now we're in 2D. And on the control node, we are going to add a texture rect. And a texture rect is just something that holds a texture, which is what our reticles will be. So go ahead and rename that texture rect to default reticle. And you're just going to want to drag the white reticle onto that texture. So you can see here, it's pretty blurry, but when you zoom out, and that's kind of what it'll look like on the screen there, it looks a lot better. One thing we need to make sure we're doing, though, is we need to make sure we set the stretch mode to keep centered. And that'll prevent it from scaling up over time and becoming very, very blurry. So go ahead and hit save on that. And let's start to code. So here in our interaction controller, we're just going to go ahead and control left click and drag the default reticle in. Actually, before we do that, make sure we are accessing this as a unique name, just to make our code base a little cleaner. Now, we also need to make sure that the reticle is in the right spot as soon as the game starts. And for that, we need to do our ready function. So go ahead and type func_ready. And now we just need to manually set the position of the default reticle. I will kind of type this out and then we'll talk about it as we get to it. So the default reticle position in the X is going to be equal to get viewport dot size dot x divided by 2, and obviously we need to do that in the y-axis as well. So go ahead and change these values to y. So what is this actually saying? So we need to get the viewport size because you could be playing the game in a windowed mode, and this also accounts for if people have different sized monitors. I'm willing to guess a lot of you are going to have 1920 by 1080 monitors. My monitors are 2K, which means they're 256 pixels by 1440p pixels. Some of you may even have 4K monitors or ultra-wide monitors. Regardless of how you're actually playing the game, you want the reticle to be centered. So get viewport just tells us what's the size of the game right now, whether it's windowed or on a different sized monitor. And so this will get our reticle in the center of the screen, although there will be one slight issue, and I want to talk about it. So let's go ahead and run the game to show you. So you can see that white dot. What you might not be able to see is that dot is not actually in the perfect center of the screen. And to demonstrate that, I'm going to come over here to our switch. So you can see the dot is not actually over the switch, but if I get close, I can click and drag down. Let me go ahead and do that one more time. So I'm not over the switch, right there, yeah. So it's actually off by, in my case, 4 pixels. And the reason for that is if we go into the 2D view, the center of the pixel is going to be up here in the top left, or the center of our icon rather is going to be here in the top left rather than the center of the screen. So we need to account for the size of the texture when setting this to be in the center. So let's go ahead and go back into our script, and we want to do this dynamically as well. And what we need to do is we need to subtract away, and the reason we're subtracting is because we're in the top left here, which means this guy needs to be pulled up and to the left by pixels, which is both subtracting, because the logic for any GUI objects is that they start in the top left. So we need to take the default reticle, we need to get its texture, and we need to get its size. And once again, we need to care about its size in the X, and we also want to divide by 2. And we're going to go ahead and copy this and paste it down here as well. And this is for the Y. And that's going to center it for us. So let's go ahead and save and run the game. Let's run over to the switch. And now, if I pull there, and then as I get very, very close, you can see it might just catch. So that is much more responsive. And now that the reticle is centered in the center of our screen, let's go ahead and talk about the other reticles. The good news is these next reticles are going to be super easy to add. It's the exact same process. So on our control, we're just going to add another texture rec. We're just going to call this our highlight reticle. Reticle. And we're going to add another texture rect. And we're going to call this our interacting reticle. We're going to right click both of these. We are going to access them as unique names. And you may have guessed it, we are going to control left click drag into our script. And now we just need to copy and paste these lines again and then replace them with the respective reticle. But we need to go into 2D real quick. We need to look at these reticles. We need to drag the open palm onto the highlight reticle. We need to put its stretch mode on keep centered, and then do the same for the interacting reticle. Drag the PNG on and change the stretch mode to keep centered. Now you may be able to see there's a problem. They're all overlapping each other right now. And essentially what we're going to do is we are going to handle the logic to toggle the visibility. So just to demonstrate that these are working, let's go ahead and get rid of the default reticle and the highlight and show the interacting one here. So you can see that's in the center of our screen. And let's do the same for our highlight reticle. All right, so now that these are showing up, let's write some logic to switch between the reticles. And before you do that, make sure you turn off the visibility for the highlight reticle and the interacting reticle as well. So down at the bottom of our interaction controller, just after our is camera locked function, we are going to write 2 new functions. It's going to be func_focus. Just going to write return for now. And then obviously func_unfocus, which is also void. And return. So when we focus on an object, that is defined as when we look and we're hovering over a potential interact object, and unfocus will be the exact opposite when we are no longer colliding with something we can interact with. So we need to set the visibility of the reticles here. So we're going to look at our default reticle, dot visible, and if we're focusing on something, we want the open palm hand to show. So this is now false. Let's go to our highlight reticle. This visibility is going to be true because we are highlighting over something we could interact with. And then finally our interacting reticle dot visible will be false because we are not interacting with this yet. So go ahead and copy those and paste them in your unfocus method. Now, if we've unfocused, we are no longer hovering over something we can interact with, which means we want our default reticle to be visible and we want our highlight reticle to be turned off. So we'll get to our interacting reticle situation in a little bit, but let's go up to our process function and see where we should be focusing and where we should be unfocusing. So here in our process function, there is one spot where we want to be focused, and that is here in this else block. So we have just found an object we could possibly interact with. We have just found out that we are allowed to interact with it, which means that, hey, we could possibly do something here. And that's when we want our palm hand to show. So after we set our last potential object, just call focus. All right, and we have a few spots where we need to unfocus, and those are going to take place up here. So here, if our input is secondary, meaning we just decided to throw the object, obviously we don't want to interact with it. So we're going to call, unfocus right there. And the other situation is here. If we're not pressing any of the objects, we have just finished interacting. We now want to unfocus here as well. Now, there will be more spots where we're going to need to call focus and unfocus once we implement the collecting logic. But this should work now for the default and the highlight reticle. So let's go ahead and test the game and see. I've actually just realized I think I forgot one. So we need to check if we were never interacting with the object. So maybe it was a potential object, but we decided not to interact with it. That is also an unfocus. So this is a situation if I hover over a box and I don't click on it and then I stop hovering over it, I want to change the reticle, but I don't want to leave the reticle. So let's go ahead and test it now. So let's run the game and test our results. So I have my default white reticle there. I see a box and I hover over it and the reticle will change. If I interact with it, however, it doesn't change. So we need to get the situation for when we're actually picking up the object down next. But as you can see, this works on doors, this works on switches, this works on wheels as well. So let's go ahead and add the logic for interacting. At the end of this series, I will be doing an episode dedicated to the Great Refactor is what I'm going to call it, where we fix either bugs or just general coding oversights that happen during it. And a lot of it is going to be some clunkiness that comes with dealing with an interaction controller. However, for the meantime, we're just going to do it the quick and dirty way to get things working. So we are going to add in the interacting logic ourselves. So we need to check if we have an interaction component, meaning that we have found an object. And then we need to check if that specific interaction component is being interacted with. So check it is interacting. Now remember, we set this in the pre and post interact. So if we grab an object, we will say that we are interacting with it. And when we drop it, we will say we are no longer interacting with it. So let's go back to our interaction controller. And if we are interacting with it, we need to set our reticles. I'm just going to copy and paste mine down here. So if we are interacting with something, we don't want the default and we don't want the highlight. We want the interacting reticle. So let's go ahead and test and see if this can get it done. And running the game, we click start. I walk over to my box. I can interact with it and I left click down and the reticle changes and the box follows it. And this also works for doors, and this also works for switches, and this also works for wheels. So now that we have the reticle there, what we need to do is actually implement picking some objects up. And to do that, we're going to expand our interaction component to add what I call items. Some might call them collectibles. Things that you can pick up and put in an inventory or in some way benefit the player. So back in our interaction component, we're going to go ahead and put a comma here. We're going to create another interaction type, and this is going to be called item. You could call it collectible. And this is going to represent anything that we can, I'm going to say collect. I'm going to say pick up to mean actually grab an object, a physical object that reacts to the environment. And I'm going to say collect to mean something that's going to disappear and go into your inventory. Now, with collecting items, we are going to have to talk about signals. So if you're already comfortable with signals, you can skip ahead to the timestamp on screen However, for those who don't know about signals, I'm going to quickly explain them. So on screen here, I've just created this area 3D right here. And so a signal is just a notification that something has happened. So specific to area 3Ds, if you go into the node and on the right side, you can see these signals. You can say area entered, area exited, bodied entered, body, etc. So the simplest example of this is if I were to fire a signal when the player enters the area. So the player is moving, and then as soon as they enter this box, something happens. It sends a signal to a script that says, hey, the player entered the area. Maybe you spawn an enemy, etc., etc. When we collect an item, we want to do the same thing. We want to send a signal to the player or maybe an inventory controller in the future that says, hey, the player picked up a health pack. The player picked up ammo. That's essentially what the signal is. They can get complicated, but for our use case, they're actually going to be fairly simple. And out of the box, certain nodes come with these default signals. So obviously, if you have an area, you're probably going to want a signal to notify scripts when someone enters or exits. However, we are going to create ours in code dynamically. So back here in the interaction component, we are going to just add a comment that says signals in case we add any in the future. And it's actually very easy to create them. Instead of var, it's just signal. We are going to call this item collected because that's what we're doing. And one important thing we're going to do is we're going to keep a reference to the item we collect. And that way we can tell the inventory, hey, the user picked up a health pack. Hey, the user picked up some ammo. And similar to picking up objects, this is a fairly simple interact just down here in the match interact type. So instead of interacting with the default, we're just going to add our interaction type dot item. And if we are trying to grab an item, we are going to call a function called collect item. So let's go ahead and copy this and write this down at the bottom of our script. This is a func collect item. This is going to be a void. Let's just return for now and talk about how we're going to send this signal. So sending a signal is actually fairly easy. You just call emit signal, and it needs to know what signal it's going to emit. And for us, that's item collected. This is the item collected we just defined up here. Now, once again, I just want to make note that we want to send the item that we're actually collecting here. So we need to add a comma here and define the object that we're sending. So let's think about what we are coding right now. This interaction component is going to sit on every object in the game, right? So for pickup items, the interaction component is going to be, here as well. So what are we actually going to send? Well, we're just going to send the parent. Because if we have a health pack, we're going to have a node called health pack. And underneath it is going to be the interaction component, the script that we're writing right now. And we want to tell our player or our inventory system, hey, this is the item we just picked up. And after we pick up the object, we don't want it hanging around. We want it to disappear. So we're just going to call getParent.queueFree. So let's actually just go ahead and create an item from scratch, something that we can pick up. So go into 3D, go ahead and hit plus and create a new 3D scene. We are just going to call this item. And we're actually going to change this type to a rigid body 3D. And as always, a rigid body 3D needs two things. It needs a mesh instance 3D, and it also needs a collision shape 3D. For the mesh instance, we're just going to create a cylinder mesh. Go ahead and drag it up. And we don't want this to be very big. We want it to be fairly small. So let's change its height to, let's say 0.3 and change these to 0.01, 0.01. All right, that's a little too small, maybe 0.1. Yeah, and we can pretend like maybe this is a soda can or something. And we need to do the same for the collision shape. So create a new cylinder shape. It needs to be, what did I make all of these? 0.3 in height, and it needs to have a radius of, what was it, 0.2? It was 0.1, that's what it was. Yep. And make sure that this is also on there. So there's our little soda can. And go ahead and reset those transforms if they got moved for you. So I think I want to add a texture or maybe just some kind of color to this. let's just make it gray so it kind of does look like a soda can. Go ahead and add our, go down to our objects. We want to add our, interaction, sorry. Add our interaction component node here, which once again is going to sit right below the parent. And we need to set this up. So the object reference is the item itself. It is an item type. We don't care about the max rotation. We don't care about the pivot point, and we don't care about the nodes to affect. However, I will point out, if you wanted something dramatic to happen when you picked up this specific item, you could add a node to effect, some kind of alarm or something to turn on. That's kind of the beauty of this interaction system, is you can pick and pull the parts that you need and just leave the stuff that you don't really care about. So let's go ahead and save this in our objects, and we're just going to call it item scene and go into our sandbox. And I'm actually just going to put it on this box. Let me go ahead and reset our player, grab our objects, and grab our item. And so now the item should sit right on the box. So back in our interaction controller script, we actually need to pick up this item. So go ahead and create a func, and this is going to be called onItemCollected. OnItemCollected is going to take in a node, because that's how we defined how we're going to pass these around. And this is where you would add it to a inventory system or call an inventory controller or something. In our case, we're just going to print to kind of tell the user that something happened. So player collected, and we're just going to, I don't know, call it, yeah, that's fine. And then make sure you add the item in so we know exactly what the item was. So now we just need to hook up the signals between our interaction component and our interaction controller, so that way we get this firing. All right, so we touched on it, but normally you would hook up signals using the Godot inspector. However, we can't do that because we have a random interaction component somewhere off in the world that the player may or may not know about. So we're actually going to have to do this dynamically. And lucky for us, part of the logic has already been written. So here, where we do the input is action pressed primary, and then we call our pre-interact. So this is the first time we are interacting with this object, and we kind of do this little exchange handshake of information between the two. If it's a pickup object, we tell it where the player's hand is. If it's a door, we get its collision point. And so we need to do a similar check here, where if the interaction type is not a door, but an item, we need to link these signals together. So how do we do that? Well, we need to call the interaction component, and we need to call a function that's built in. So we're going to say connect. And so the first thing we need to do is get the signal name from the interaction component. And if you remember, we called that item collected, I believe, right? Up here, yep, signal item collected. Now, the next thing that this needs is a callable. And the callable is just, something that needs to run. So what are we, let's just go ahead and write this out. Callable self, and then what are we calling? We're calling on item collected. So all this is saying is that when this signal fires, it should be linked to this callable. Well, the callable is calling this function, which is on item collected. And what is that function on? Self, because it's in this same script. So now when we first press the primary button and we do our pre-interact, if it is an item, we're going to link up the signals. So let's go ahead and hit Control S, and let's test to see if this works. So here is our object. Let's walk up and left click, and I'm going to hit escape, and there it is. You can see player collected item, rigid body, blah, 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 blah. And so that's just printing out the item name and some other garbage. Like I said, if you had an inventory system all ready to go and fleshed out, you could do a lot more with this, but I think this is a nice, simple use case for collecting items. So let's go ahead and go back into our sandbox here, and let's just go ahead and look at our item here. I'm just going to tinker with this. You don't really have to do this and follow along, but let's just go ahead and add a few more items here on this box. So one thing that I really like about this controller that we're building is that everything is a physics body. Everything interacts in space. There's nothing static, and it feels very alive. So just to show you that, here we could have, 4 soda cans or 4 health packs sitting on a box. If I pick up the box, the soda cans go with it. If I chuck the box, well, you can see I kind of messed that up. But now it's rolling and I have to pick them up off the ground. If I hit escape, you can see we picked them all up. I just think the game feels a lot more alive when everything feels like it can be moved and interacted with. And now that we have 4 soda cans, or whatever you want to call them, let's go ahead and run the game, and I'm going to show you some limitation that we need to come over real quick. So as you can see here, I have multiple cans back to back, and if I'm just looking at this first can, but you can see the raycast is going to hit the second one. If I left click, it's going to pick up both of them immediately. And if I come over here, it'll do the same thing. Now, if you had some kind of a sound effect or something you wanted to play when you picked up the first one, that might feel a little clunky, or maybe you want the player to have to manually click to pick things up. But this can be easily overcome. So let's go back to our code and talk about it. So back here in our code, we have this if input is action pressed. All we have to do is _just. So if the is action just pressed, and this will force you to have to left click on every pickup item. So let's go in here. I see this item. We're going to do the same test from before, and I left click and keep it held down. Nothing. I have to manually click on all of my things, and everything else should still be working, which is good to see. So that's another little simple fix for the collectibles. So I know I talked about it briefly in the throwing and picking up objects episode, but if this wasn't such a well-lit scene, if this was a dark horror game like I envision building myself, these objects may be obscured in some kind of fog or something, which may make it difficult for the player to actually find them. So I'd like to do some kind of outline shader, so when the player is within a certain distance of the objects, they'll kind of light up and pulse to be like, hey, you should come pick me up. That means we're going to get into some shader code here, and this might feel complicated, but I'll try to explain everything as best I can. So to do this, we're going to want to click on our item. We want to go into this scene, and we want to open the Mesh Instance 3D. We want to go to the override we created, and we want to add a next pass. And this next pass is going to be a new shader material. So go ahead and open that shader material. And we're just going to go ahead and right click and click new shader. Now we actually need a new folder for this. So we're just going to create a new folder, and we're going to call it shaders. Create a new shader and put it in the shaders folder. And we're not going to call it item. We are going to call it outline shader. Go ahead and create. And if you double click on it, you'll see down here in the bottom, we get this shader code here. Now, shader code is not particularly difficult, but it does kind of go beyond the scope of this video here in this explanation. So for the sake of that, I'm just going to go ahead and leave a paste bin, or maybe my top pinned comment. We're just going to paste in the shader we want. This is taken, I believe it's called the Godot Perfect Outline Shader. Correct me if I'm wrong. We'll get into shaders probably later into the tutorial series, depending on how far I take it. But just for the sake of this episode, we're going to go ahead and paste it in. So go ahead and copy and paste it in. And now that it's pasted in, you can see we can expand some of these parameters. So I want my outline color to be like a nice pale blue. I want it to be kind of dramatically wide. This doesn't look particularly good, but I want it to kind of stand out for the sake of the tutorial. I don't know how much it's going to show up on YouTube videos. And as you can see here, it's kind of pulsing back and forth. Now, we don't want this always, because right now, if we just run the game, those are all, look at that. Those are always going to be pulsing like that. Perhaps that's a little dramatic. Maybe we should put this down to like 2 or something. You can see that these are always going to be pulsing blue, which isn't really that ideal. You kind of only want it if the player is right nearby and you don't want them to miss them. So to do that, we're going to use the area 3D and the on-bodied entered signals I talked about earlier. So let's go ahead and go back to our player and set this up. So here on our player, we're just going to left click, hit Control A, and add an area 3D. And just like everything else in this engine, an area 3D requires a collision shape. So this collision shape, I am going to do a sphere shape, I believe, and I think I want to do a 5 meter radius. That looks good. So any objects within 5 meters of the player in a circle should glow. I think that's a good distance. We're going to change the area 3D into interactable check and go ahead and save. So let's go into our interaction controller script. we're going to need a reference to our interactable check. Go ahead and hit Control, left click, and drag. And then down here in our ready function, we can set up the signal. Go ahead and say interactable check. And we are going to define these based on whether whether the object has entered or exited the area 3D. And we'll give a demonstration of this in a little bit. But for now, just say interactable check.bodied entered.connect. And we're going to connect that to a script called onBodyEntered. And then of course we are going to do the same exact thing, but instead of underscore bodied entered, body exited, and we will say on body exited. Now it says we need a function for these, so let's go ahead and create those. We have a func on body entered, and we'll just return for now, and we'll do the same down here on body exited, and just return for now. Now these functions, we do need to know what is actually entering and exiting. So go ahead and add an argument, which is going to be some kind of node 3D. Oh, there it is. Wow. Caps lock, people, it really hurts. Anyway, do that for both functions. And there we go. Let's go ahead and write some logic to get our outline pulsing when we are within range and back to normal when we are not. All right, I am going to add some enters and just make sure this is in the center of our screen. If the body has entered, the first thing that we need to worry about is if the body that enters this is the player. So if body.name does not equal the player. And the reason we're doing this is because the player is inside of the body, so you don't want this to fire. I'm sure there are other ways around it, but this is the simplest and cheapest way for us to do it right now. So we need to get the name of the body, and then we need to get the interaction component, which I'm just going to call IC for the sake of typing. So we're going to say body.get node or null. And obviously we want to get the interaction component. So now that we have the interaction component, we want to check if it's not null. And we want to make sure that it is, I believe we can just say interaction type. And if that is equal to the item, then we're going to do something. I'm just going to write return, because we do need to set up one more thing, interaction type. This is actually IC.interaction type. So we need to set up one thing before we can actually change the outline, but I'll go over this briefly. So make sure we're not trying to do this on the player. We want to make sure that this is an interactable object, and we also want to make sure that it's not just a door or a switch. We want to make sure that it's a pickup. So let's go ahead and do some of the same logic for when we leave. Once again, we want to make sure that we aren't colliding with the player on accident. And I think we're going to leave this one here as well. And the reason why is we actually need to save this shader as a material, so that way we can just apply the material to the material overlay. And how we're going to do that is we are going to go back to the 3D view for this, and come over to our surface material override, and we're just going to right click on the shader material, and we're going to click save as. While it's not technically a shader, actually let's just go ahead and create a folder for this. Right click, new folder, and we'll call this materials. So go ahead and right click this, save as in the materials folder, and we are just going to call this outline. So now that that's saved, we need to go back into our script here, and we actually need to load this material at the start of the class. So up here, we are going to create our own onReady. So this is going to be an onReady variable. I'm going to call outline material. The type is going to be a material, and we are going to call preload. And we actually need to path to where this is. So it is in materials outline dot resource. So now that we have the outline material, which just represents the shader here, let's go ahead and scroll down and get rid of our return statement here. So what are we actually going to do here? Well, we need to get the mesh of the object, of the item, the soda can we're picking up. So the mesh is the mesh instance 3D. And so we want to do find child, and we want to find the mesh of the child. Just like that. And then we want to take the mesh and we want to set its material overlay to the outline material. And then when we are out of range of picking the material up, we want to do the same exact call. We want to get the mesh instance 3D, and we want to double check to make sure that this is not null, and we want to call the material overlay, and we just want to set it to null. And the reason we need to check is that this might fire twice. The collisions are kind of funky in Godot, so we need to make sure that we haven't already cleared the overlay. So let's go ahead and run Godot and see what happens. Actually, before we do that, we need to get rid of that next pass there. So let's go ahead and run it now and see what happens. All right, so here we have the blue pulsing outline. Let's say I run over here. It's not showing up, and as I walk slower towards it, it appears. Let me back out again, disappears, pull up again, and they appear. I think to show this better, I'm going to go into my player, I'm going to go into this collision shape, and I'm going to change this to something like 2 meters, maybe 3 meters. Yeah, maybe 3 meters. That might be more clear. So let's go ahead and run this. So I'm out of the range, there is no pulsing, but as I walk up, there is now pulsing. So if the game is dark, these will show up a lot more clearly, and you can tinker with the brightness or add in your own kind of shader here, and you now have the logic to do so. But this is just something that will make picking up these objects a little bit more intricate. So I hope you enjoyed this tutorial, and I will start working on the next one.